Welcome to part 3 of the Python course. This section covers control structures in Python, or to put it in simple terms, giving your program some intelligence. In this section, we will cover two types known as selection and iteration. So we've got selection, which is the decision-making control structure in Python. This allows your code to branch to certain places. The second type of control structure we're going to look at is something called iteration. And iteration basically means repeating lines of code over and over again. Both these structures use something called a relational expression. And a relational expression is an expression which uses a relational operator. And a relational expression simply evaluates to either true or false. Nothing else. Okay, the first type we're going to look at is selection. And selection, the most basic structure for selection is the if structure. We can then move on to the if-else structure, and finally we have the largest structure, which is the if-elif-else structure. How the structure is put together is every time there's an if, you need to check a relational expression. So we say if, and then a relational expression is tested. If the relational expression is true, certain lines of code are executed. If that relational expression is false, then your program will jump down to the else part and it will execute code based on the relational expression being false. So let's start off quickly and have a look at a nice, easy example. I'm going to start by creating two variables, A and B, and I'm just going to give them two values, 41 and 42. And then I'm going to put together an easy relational expression. I'm going to say if, and then the relational expression I'm going to use is A greater than B. Now that colon at the end of that first line tells Python that this is the start of a particular control structure. And you'll notice that when I press the enter key now to move from that line to the next, Python will automatically indent my code. Now we spoke about indentation earlier in the course, and I said that indentation was extremely important because it indicates to you a complete code structure. All the code that is inside this if statement must be indented by the same amount. Otherwise, Python simply will not run that code. So the code that's indented now is going to be executed if that relational expression is true. So let's just put down a simple print statement, and I'll say print A is greater than B. Now, if I run that code, you'll see that nothing happens because A is less than B at the moment. Okay, so basically A and B, I've changed to 43 and 42. So if A is greater than B, it checks that relational expression based on those two values. A has a value of 43 and B has a value of 42. Which means that that relational expression is going to evaluate to true. And if it is true, it then runs that line of code. What was happening was initially I had A at 41 and B at 42, which means that this evaluates to false. And that means that that line of code is not being executed. So if I had to run that now, we can see that there is no program output. If I make this bigger, we then have a program output which executes. All right, let's build on this and make it a little bit bigger. I'll go A comma B equals 41, 42, and now I'm going to put together a full if, elif, else structure. So I'm going to say if A is less than B, The output is going to be A is less than B. Now I'm going to use the LF command. LF basically is short for else if. And because there's another F in there, it means that we need to check another relational expression. This time I'm going to say A greater than B. Again, we are checking a relational expression, so we need another colon at the end of that line. When I press enter, the code will automatically be indented. So I can say print A is greater than B. And finally, I can put the else statement in there. What is that going to do? If that relational expression is false and that relational expression is also false, your code is going to jump down here. So if A is not less than B and A is not greater than B, it means that A must be equal to B. So we can have a print statement in here just saying A is equal to B. There we have it. So if I had to run this structure now, what will be displayed, because A is 41 and B is 42, it should evaluate that as being true, so it should print out that line. And if I run it, we can see that it does. It says A is less than B. If I change this and I run it again, it now says A is greater than B. So when A was 41, that was true, and it printed out that statement. Now that A is 44, that is false, so it then checks the next relational expression, and because it's true, it prints out that statement. If I make them equal, now it's going to test that. That will be false. It will check that relational expression. That will also be false. So it will now tell me that A is equal to B because it runs that particular statement. Okay, let's have a look at another example. If I say temp, this time I'm going to use an input. I'm going to say int input into the temperature. In degrees Celsius. All right, so that should work. So what I'm doing now is I'm using the input statement, asking the person to enter a temperature in degrees Celsius. I'm then converting whatever you enter into an integer and then moving it over to the variable called temp. And now I'm going to put together a simple if structure. I'm going to say if temp is greater than or equal to 20. Let me use the print statement again. I'm going to say print, let's see, it is nice and warm today. I'm going to now check again, and I'm going to say temp greater than or equal to 10. Use the print statement, and I'm going to print out today is cool. And finally, I'm going to use else, which will print out a statement that says today is very cold. So let's have a look at how this works. Program is going to ask for an input, and then it's going to use that input and check relational expressions. Based on what the person has inputted, it is then going to print out a specific response. So if I run that, it's going to ask me for the temperature in degrees Celsius. If I type 25, it then comes back and says it is nice and warm today. Why? Because that relational expression was true, and therefore that is being displayed. If I run this again and I enter a value of 18, it displays today is cool, because 18 is tested inside the structure. The first relational expression is tested, and that is false. It will then move to the next relational expression. It checks that and sees that it is true, so it then displays today is cool. Finally, if I had to run this and enter something like 7, it will come back and just say today is very cold, because that relational expression is false, that relational expression is false, so it will then jump to the else part of the selection, and it will then display the last statement. So let's move on now to the next type of control structure, which is something known as iteration. And the first structure I'm going to look at in iteration is the while loop structure. Basically, in this structure, a relational expression is checked. Just like all other control structures, it needs a relational expression. So the relational expression is checked and code is repeated while the relational expression is true. So relational expression is checked and code is going to be repeated until that relational expression becomes false. So if the relational expression is true, your program will remain inside that structure. So let's have a look at the actual structure of that code now. We start off with the word while. Not sure what's going on here. While. And then we check the relational expression. This relational expression is tested and then again indented in your control structure is all the code that you want to execute while this relational expression evaluates to true. As soon as that relational expression becomes false, this code will no longer continue to be executed. All right, so let's have a look at a simple example using this iteration. I'm going to start off with a variable I, and I'm going to make it equal to 1. Then I'll say while I is less than 10. All I'm going to do now is to print out the value of I. Now, this is extremely important. If you are using a while loop structure, you need to make sure that there is code inside the structure that will update the value for I. If I look at it now as it is, and it says I equals 1, and then it says while I is less than 10. So that is going to evaluate to true, which means that it's going to run this line of code and it's going to print out the value of I. So you should see 1 being displayed. And then, because it's a loop structure, the structure is going to go back and check the relational expression again. But I will still be 1, so it prints out 1 again, and it will continue to do this forever. This is something known as a non-terminating loop, or an infinite loop. So an infinite loop is caused when you don't provide code inside the structure to update the variable that's being checked. So what we need to do here is to add some code in there which will increment or decrement the value of I. So incrementing the value of I like this will then cause your program to display the following. This relational expression is being tested, and it starts off with the value of 1. So 1 is less than 10, so it prints out the value of 1, and then it increments I by 1, so I becomes 2. It then checks the relational expression again, that is still true, so it prints out the value of 2, and then it increments it. And it will continue doing this until I becomes 9. When I becomes 9, it prints out the value of I. You will see 9 displayed. It then increments I, so 9 plus 1 is equal to 10. It will then check that relational expression, which now evaluates to false. And because it's false, that structure is then exited. All right, so this time I'm going to write a little program which asks the user to enter a number. So I'm going to start off by tricking it. I'm going to say num equals -1. And now I'm going to put together a loop structure. I'm going to say while num is less than 0 or num is greater than 100. I'm now going to ask the program to allow you to enter a number. I'm going to say num equals, I'm going to use an integer, so I'll say int input, enter a number from 0 to 100. And then just to check what was entered, I'm just going to print it out when that loop is exited. I'm going to say you entered. No. Right, so let's have a look at what I've done here. I'm asking the person to enter a number from 0 up to 100. So you should be able to enter any number from 0 to 100. It will be a whole number, but of course you could use a float if you wanted to. And your program is then going to be checking whether this value of num is between or in the range from 0 to 100. And if it's not, it's going to repeat this question. So it's going to continue to ask the person to enter a number until they enter that number in the correct range that you've asked for. So let's have a look when you run this. It's going to say enter a number from 0 to 100. So if I try and trick it and I say, well, let's start off with -10, you can see what happens. It takes that number, it checks it, and then it simply asks again. So enter a number from 0 to 100. This time I'll put in 105. Again, it doesn't accept it. Enter a number from 0 to 100. If I do enter a number in the correct range, it will then accept that number and continue with the program. So it just displays the number I've entered. All right, so it's a simple little trick to make sure that your program enters a specific number that you are required. So for example, if you're writing a program which asks the person to enter their age, and you want the age in a specific range, let's say the range from 18 up to 90, all right, then you can use this program to look for that specific range, and it's quite useful. All right, so there's one little use of the while statement. All right, we spoke about infinite loops up here if we do not provide that statement. So what I'm going to do now is just look at another example, which is quite important. If I say a equals 1, and then I put together a while statement which says while a equals 1. This statement I am going to run. Okay, so please be very careful when you are checking an equality. Equality means you're checking a value is equal to a specific value inside a while loop. This is another example of how an infinite loop could be created. All right, so this is a bad example of creating an infinite loop. All right, I'm obviously not going to run that because it's just going to cause a problem. Right, the next iteration statement we are going to be looking at is the for statement. And this is also iteration, which means it creates a loop. Basically, what this allows you to do, it allows iteration through a sequence, and we can do this element by element. We haven't looked at sequences yet, so don't worry about that too much, but we have actually had a look at one sequence already, which is something called a string. So that's what we'll use for an example. To actually do this, the syntax we use is quite simple. We start off with the word for, and then we have a variable, and then we use the word in, and we list the sequence we are using. So let's have a look at how we can put this together. I'm going to create a string, which I'm going to call words, and that string will be Monty Python. Then I can create a loop structure using the for. So I'm going to say for, let's create a variable, I'll call it k in words. So basically what's happening now is that it's going to be using that sequence, which is a string, and that string is Monty Python. And it's the for loop is going to run through each value inside the string called words. And all I'm going to do is to print out the value of k. So if I run that, see what we get. It runs through each value in that string and it prints it out to the form. So we've got M, then O, N, T, Y, then a space goes into K that gets displayed. So on every single line, we end up with one character which is extracted from that string. We could create a different loop by saying for K in words. This time I'm going to use the print statement. I'm going to print out K, but I'm going to use end equals a comma. So this time when I run it, have a look what happens. It now extracts each character inside the string words, and it uses a comma between each character. All right. This is a very handy way of creating a CSV file, which we'll have a look at later in class. So there's a good example of how CSV files can be created quite easily. All right, let's do another little example. I'm going to start off by counting something inside a sequence. So I'm going to start off by creating a variable, which I'm going to call count, and I've given it a value of 0. And then I'll say for K in words, I'm going to say if K is equal to, let's choose the letter Y, for example. I'm going to say count plus equals 1. And then I can print out there are all right, let's have a look at what happens now. So if I run this code, it again is going to go through the sequence words and it's going to extract each character. And now it's performing a check. It's using the if selection to check to see if that character is equal to the character y. And if it is, it's going to increment our count. And at the end, it will then simply display the value of that count. So when I run this, it comes up with an error. Let's see what I've done. Of course. Okay, that is a control structure, so it needs to end with a colon, and that is inside. Right, so when I run it, it's now running through all the values in the string Monty Python, and it's counting the number of y's that we've got. And it comes back and says there are 2 y's in that string. If I change this to, let's say, an H, and I run it, there are 1 H's in the string. Okay, change this to an O. Again, it comes back, there are 2 O's in that string. There's 1 there, and there is 1 there. All right, so this is a quick example of showing you that we've got a loop structure. It's an iterative loop using for, and inside that structure, we are now using an if statement, which is a selection criteria. All right, so again, nice and easy loop structure. There are 2 types. We've got while loops and we've got for loop structures, iterative loops. The next introduction is going to be something called the range function. Now, the range function is quite important because the range function can automatically generate a range of integer values only. Very important, the range that it generates are integer values. To be able to use the range function, the syntax is as follows. We type the word range, and then inside parentheses, we can specify a starting value. We then specify an end value, and finally we specify the increment, sorry. By default, the start value is 0 if you leave it out, and if you leave out the increment, it has a default value of 1. So let me just put those in there. Defaults equals 0 and increment equals 1. All right, so why I've made the end statement bold is because end has to be specified. You cannot leave out the end. You can leave out the start and the increment, but end has to be given. Python needs to know when the end is going to come about, or in other words, when the loop structure is going to end. So let's have a look at how we can use this for statement. I'm going to use a simple structure. I'm going to say for I in range, and I'm going to say I want you to start at, no, I'm going to just put a 9 in there, and then I'm going to print out the value. I'm going to print I, and I'm going to say end equals a comma. So if I run that, we can see what happens. We get a range of values starting at 0 and ending at 8. Now this is important. We specified the end value as being 9, and Python will go up to but not include that last value. So the value that is given as the final value is 1 less than the end value. Now let's have a look why. We've asked it basically for 9 values, all values, integer values ending at 9. So if you count this, you will notice that Python always starts with the value of 0 unless it's specified. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values. The number 8 is actually the 9th value that has been extracted. If I change this to add in a start value, I'll ask it to start at a value of 2. If I run it now, we can see that it starts at 2, and again it ends at one value less than 9, which is the 8. So we've got 2, 3, 4, 5, 6, 7, 8. We can also add in an increment, and the increment here, if I ask it for an increment of 2 and I run it, we can see now that it increments every second value, so it displays all the even values in that range between 2 and 9. So we've got 2, 4, 6, and 8. All right, so the range function is very simple to use. We give it a starting value, an ending value, and an increment. The only value that is necessary is the end value. And if you leave out the start value, it defaults to 0. If you leave out the increment, it will default to a value of 1. All right, let's look at a few more examples. For I in range, let's go for a value decreasing. So I'm going to start at 10. I'm going to go down to minus 11 with an increment of minus 2. And I will print out I, and I'll end it with a comma. So when I run this, we'll see now that the range starts at 10, and this time it decrements. So we're basically incrementing by a value of minus 2. So it subtracts 2 from that value each time it runs through this loop structure. Okay, it's still a loop structure because we are using the for iteration. And this time, where does it end? It's going to end at a value of minus 10, which is 1 less than the end value that we've specified. All right, let's now use this in a real world example. Let's say I want to display the powers of 2 of all numbers as the increment. So I'm going to start off with creating a variable. I'm going to call it 2, and then I'll say for POW in range 13. So I want values to go from 0 up to 12. And then inside I'm going to say print I to the power of equals, and finally I'm going to put the calculation in there, calculating the power. So each time it runs through this loop, it's going to print the following to the form. It's going to say I, which is 2, to the power of, and then it's going to extract the value that's being generated by this range function. And then it's going to display the answer, which is I to the power of that number. So when I run it, we end up with something that looks like a table, giving you all the powers of 2 from 0 up to 12. So in other words, 2 to the power of 0 is 1, 2 to the power of 9 is 512, 2 to the power of 12 is 4096, and so on. If you didn't want to the power of, you can change this to whatever you want. So I could change it to this little symbol, It might make a little bit more sense to some of you. 2 to the power of 10 is now 1024. Now, because we are using variables and we are using a loop structure, we can change these values to whatever we want. So if we want, instead of powers of 2, if we want to change this to 5, and I run it, we've now got powers of 5. So 5 to the power of 6 is 15,625. So you can see how easy it is to generate large amounts of data inside a computer program which is using a loop structure. I hope you enjoyed this introduction to control structures in Python. If you enjoyed it, please don't forget to subscribe to the channel for more videos coming up. Thank you.